Welcome back once again to our favorite channel, Dynamic Thinker. In today's session, we are still going to talk about land surveying, and today we are looking at how to care for chains. So our term it as care for chains. Okay, so when you have a faulty chain, you can't go to the field using your faulty chain unless you want to do some systematic calculations at the end of your survey. But there are 5 simple steps you can follow to correct your faulty chain. So the first step is 1. You select a suitable area. Select a suitable area such as a veranda. So the importance of this veranda is to help us have a very flat surface or a straight surface to prevent undulation, which will lead to sunburning of sunrays. So we select a suitable surface. Now the second point is using a good tape. So using a good tape, mark out the length. Mark out the full length of the chain and also locate the midpoint. So with this, you are going to use a good tape to mark out the full length of the chain to be corrected. That's the chain in question here. And you locate the midpoint. So if this is my veranda, I have my 40 chain. Let's say this chain is my 40 chain. So using a good tape, which is this one, I mark out the actual length. Let's say from here to here. So I mark them out on the veranda, locating the midpoint to as this side. So that's it for that one. Then the next thing is, after that, you lay the chain. You lay the chain between the mark length. So 3. Lay the chain to be corrected in the mark length. So since we saw it this way, we had this. Now our 40 chain we kept here. So let's take this one for instance, exceeds the mark out. So let's say this is the midpoint. So we now lay the chain between them. Now the next thing we are going to do is we are supposed to inspect the chain and straighten any bent lengths or any open rings. So with this one, I'll be inspecting the chain. So when I come here, I can see that there is a bent length. This side too, there is still a bent length. So I will straighten them, and when I straighten them, it looks like this. So that's the same thing that will be done till you get to the end. So the next thing is inspect. So 4. Inspect the chain. Inspect the chain and straighten all bent lengths and close all open rings. So after this method, you now have your chain looking like what I'm about to draw. So you now have your chain looking as such. Maybe your chain exceeds. Now you measure the actual length, or you find out the actual length of the chain. So when I found out the actual length of the chain now, maybe this, the measurement I want to maybe 30 meters, then it means that I have to delink it by taking off this length away. So the fifth one is find out the actual length of the corrected chain. So with this, if I found out that my range is, let's say, within the range of 30 meters, the reason why I'm using 30 meters is because you have a 30 meter type A and a 30 meter type B. So with this one, if I want it up to 30, I delink it and I keep the ending point of the chain at this very point. If I want to use it that way, then it means I have to find for the actual distance from the starting point to the ending point, and I have my actual distance or my actual length. So this is the steps one has to go through to correct his or her faulty chain systematically before you take them to the field. So moving on, we are going to look at determination of variancy. Let's take it as if you have a question as such, that the forward bearing of a line is 30 degrees. Show its illustration why the back bearing should be 210 degrees. If there is no local attraction or observational error. Perfect. Now mathematically, the difference between the forward bearing and the back bearing should have been 180 degrees. And hence, me showing with illustration why the forward bearing is supposed to be 30 and the back bearing is supposed to be 230 means that if my forward bearing is equivalent to 30 degrees, then it means automatically 30 plus 180 give me 210 degrees. And to show this with diagram, so this is how it's going to look like. How it's going to look like. I stand at station A with my measurement. Taking into consideration an angle theta, let's say theta 1. Moving to station B, I have this angle being equivalent to this angle, so let me label this as theta 2. Now my movement from the North Pole to this side, I'll label it as alpha. Now to get theta 2, note that theta 1 is equivalent to theta 1, so theta 1 is equal to theta 2. But let's ask ourselves, how can I get theta 2 if I don't have theta 1? That means that to get the value of theta 2, it means whatever value, that's 180 plus that theta. So this becomes equation 1. Now to get the value of the alpha, alpha is the distance traveled from the North Pole to our present line here. So we should note that the whole of alpha is going to be alpha is equal to 180 degree plus our theta 2, which is the value here, will give us the total distance traveled up to this point. Fair enough. So this becomes equation 2. And also again, since we are saying theta 1 is equivalent to theta 2, we can still have alpha as being equal to 180 degree plus theta 1, and this is equation 3. Now to prove that the back bearing and the forward bearing, the difference between them is supposed to be 180. We can do some change of subjects to see the various outcomes here. And this change of subject, we're going to have alpha minus theta 2 to be equal to 180 degrees. And again, alpha minus theta 1 is equal to 180 degrees. This shows that the difference between the back bearing and the forward bearing should always be equivalent to 180. So bringing this knowledge to this, it means that after proving all these things, you are supposed to come down and show him that when you have 30 degrees plus 180 degrees. We're going to get 210 degrees, and this can be shown as A 30 degrees moves across a distance. This is your north pole, your east pole, your west, and your south. This side are alternating angles, so automatically this side also becomes 30 degrees. Now taking the measurement, this is station B, this is station A. What will be the total distance from point N to this line? Means that 180 degrees plus 30 degrees, since we said theta plus alpha plus theta 2 is equal to 180. So when you do that same change of sign, you end up getting 210 degrees as your answer. Hence, moving on. Let's take this question into consideration. We are going to use what we just did. If the back bearing reached 222 degrees instead of 210, what will be the magnitude and direction of the local attraction if still the forward bearing is there? So let's create a diagram for this. Creating a diagram, I know this is my north, this is my south, my east. In normal circumstance, the forward bearing, which is station A, was 30 degrees, and automatically I should have gotten what here? 30 degrees. But this time around, from the north down to this side, I'm reading 210, but they said I should read 222. So meaning that what will I add to it to give me the value of this distance? Automatically I come. The difference between the forward bearing and the back bearing is always supposed to be 180, and hence here 222 degrees minus 30 degrees. Let's see what it gives to us. So this gives us 192 degrees. This is telling us that the difference is not 180 as we expected. So the difference between this becomes 12 degrees. Now the 12 degrees becomes the value of this smaller angle here. But now they said what will be the magnitude and direction of the local attraction. So you come down and see local attraction is equal to, and you come down 12 degrees. Now this becomes the magnitude, and the direction of the local attraction becomes 12 degrees west. Perfectly done. And this gives you whatever mark you are searching in your exams. So moving on.